In this video, we're going to be filling out the worksheet for 7.1 on trigonometric identities. So first, our task is to write the trigonometric expression in terms of sine and cosine, and then simplify. That means anything that is not already a sine or cosine needs to be rewritten as sine or cosine. So number 1, where we have sine of x times secant of x, I need to rewrite the secant of x using sine or cosine. Well, I remember that the secant of x is just the reciprocal of the cosine, so I can rewrite the secant of x as 1 over the cosine of x, if they are reciprocals of each other. Okay, that means I have the sine of x times 1 over the cosine of x, which is the same thing as having the sine of x over the cosine of x. Well, what is that? Sine divided by cosine is tangent, so that's tangent of x. So that's the most simplified form of that. Number 2, the tangent of theta times the cosecant of theta. Let's rewrite everything using sines and cosines. I know tangent is sine divided by cosine, so sine of theta over cosine of theta. And I know cosecant is the reciprocal of sine, so 1 over sine of theta. Now when we simplify, you'll notice there's a sine on the top and a sine on the bottom. They cancel out, those sines of thetas, leaving us with 1 over cosine of theta, and of course 1 over cosine of theta is the secant of theta. Number 3, let's rewrite everything using sines and cosines. So secant of x is 1 over cosine of x minus cosine of x over sine of x. All right, now we have everything in terms of sines and cosines. So how can I simplify this? Well, I can take what's in the numerator there, the 1 over cosine of x minus what's really a cosine of x over 1, and I can combine those into one fraction by getting a common denominator. The common denominator will have to be cosine of x. So the first fraction won't change. The second fraction will become cosine squared x over cosine x, because I will have to multiply the top and the bottom of that by cosine of x to get a common denominator of the cosine of x. So we're there. Well, that means we have 1 minus cosine squared x over cosine x when I combine those two fractions that are in the top into one fraction. And then that's divided by the sine of x, but that's really multiplying then by the reciprocal of the sine of x, so 1 over sine of x. That means 1 minus cosine squared of x over cosine x times sine x. Let me move down the page here. Clearly didn't give enough space on the page for this. That's all right. We'll just go down the margin here. Okay, 1 minus cosine squared is sine squared, because sine squared plus cosine squared equals 1. Now I have a sine of x that's on the top and on the bottom. So I can cancel the one on the bottom with one of the ones that's on the top, leaving me with just sine of x over cosine of x, which is, of course, the tangent of x. That whole thing just becomes the tangent of x. Pretty cool, right? Yeah, I know. All right. If you take out your book, on the inside back cover of your book are all of the trig identities that we're going to be learning in this chapter. There's a lot of them. Right now, all we're focusing on are these ones called the fundamental trig identities. So that's what you should be using as your toolbox, your toolkit for these problems. Let's use those to simplify these expressions. Sine of theta over cosine of theta plus cosine of theta over 1 plus sine of theta. Well, what is the common denominator? It would be cosine of theta times 1 plus sine of theta. So in order to get the common denominator on the first fraction, I have to multiply by 1 plus sine of theta over itself. In order to get that common denominator on the second fraction, I have to multiply by cosine of theta over itself. So you see how I got that common denominator? Now let's simplify everything into one fraction. I'll distribute that sine of theta into that parentheses there. You get sine of theta plus sine squared of theta. And then in the other fraction, I have a cosine of theta times a cosine of theta. Well, that's cosine squared of theta. All over cosine theta times 1 plus sine of theta. Well, what is sine squared plus cosine squared? It's just 1. So in the top there, I have sine of theta plus 1 over cosine of theta times 1 plus sine of theta. Notice anything? I do. I see a sine of theta and a 1 on the top, and a sine of theta and a 1 on the bottom. So if I treat that as one factor, I can cancel that whole thing out. Cosine of theta is still on the bottom, so it's 1 over cosine of theta, which of course is the secant of theta. Exciting, right? So number 2, which I have so little space to do now. Sine of x plus cotangent of x times cosine of x all over cotangent of x. Oh, let me see if I can get myself some more space to do that in. All right. So we have sine of x plus cotangent of x times the cosine of x all over the cotangent of x. Well, what is cotangent of x? According to the fundamental trig identities, cotangent of x is 1 over tangent of x. The tangent of x is sine of x over cosine of x, right? So the cotangent is just the reciprocal of tangent. We know that, right? The reciprocal of tangent would be cosine over sine. Cosine of x over sine of x. So let's rewrite the cotangent of x as cosine of x over sine of x. I'll do that in both places where I see a cotangent. So notice what happens on the top. I have sine of x plus cosine of x times sine of x times cosine of x. Or sorry, cosine of x over sine of x times cosine of x. That cosine of x is just cosine of x over 1. So those multiply together as cosine squared of x over sine of x. Okay? So now I've got those two things on the top. I'd like to combine them into one fraction. Right now it's sine of x over 1 plus cosine squared x over sine of x. Get a common denominator of the sine of x. So multiply the first fraction by sine of x over sine of x. Sine squared x over sine of x plus cosine squared x over sine of x all over cosine x over sine of x. So now that I have the common denominator on the top there, I'll combine those into one fraction, giving me sine squared x plus cosine squared x over sine x all over cosine x over sine x. Well, what is cosine squared x plus, or sine squared x plus cosine squared x? According to the fundamental trig identities, it is 1. So I have 1 over the sine of x over the cosine of x over the sine of x. But dividing by that fraction on the bottom is the same as multiplying by its reciprocal. So multiplying by sine of x over cosine of x. So that means there's a sine of x on the top and on the bottom. I cancel them out. I get 1 over the cosine of x, which is, of course, the secant of x. Pretty cool. Pretty cool. Okay. One of the things we're doing in this chapter is proving trig identities, showing that an equation that we're given is in fact true. So showing that the left-hand side equals the right-hand side. So our procedure for that is going to be to start with one of those two sides, either the left-hand side, the LHS, or the right-hand side, the RHS. Manipulate that one side to show that it becomes the other side. It's easier, typically, to start with the more simplified, to start with the more complicated side to make it more simplified, rather than take something that's simplified and try to somehow make it more complicated. Here are some tips. If you have fractions, get a common denominator and add them together. If you have a quadratic expression, factor it, and then apply the fundamental trig identities. So here we go. Number 3, cosine of theta times, parentheses, secant of theta minus cosine of theta equals sine squared of theta. So we're going to start with the more complicated side. Which side is the more complicated side? The one on the left, I think, is more complicated. Adding and subtracting is more complicated than multiplying. So we'll start with the left-hand side, and we're going to show that it equals the right-hand side. What is then something that I can do with the left-hand side? Well, I can distribute the cosine, so let's do that. Cosine of theta times secant of theta minus cosine of theta times cosine of theta. I'm just taking the left-hand side. I'm not going to rewrite the whole equation. I'm just going to take the left-hand side and show that it becomes sine squared of theta, which is the right-hand side. Okay, well, I know secant of theta is 1 over cosine of theta. It's the reciprocal of cosine, and that's one of my fundamental trig identities. And then I know that cosine of theta times cosine of theta is cosine squared of theta. So I have cosine of theta over cosine of theta minus cosine squared of theta. Well, what is cosine of theta over cosine of theta? That's 1. So I have 1 minus cosine squared of theta. What is 1 minus cosine squared of theta? Well, I look at the fundamental trig identities and I see that sine squared of x plus cosine squared of x equals 1. So what is 1 minus cosine squared? Well, that would be the same thing as just sine squared if I subtract the cosine squared to the other side. So anytime I see a 1 minus cosine squared, I'm going to replace it with sine squared. In this case, sine squared of theta. Hey, look, that matches what I was told it should be equal to. So now I have proven that that identity is true. So that's my goal every time. Start with one of the sides, manipulate it to get to the other side. And then I've shown that it's true. Number 4. 2 tangent x secant x equals 1 over 1 minus sine of x minus 1 over 1 plus sine of x. So we're going to start with the more complicated side. Which side is the more complicated side? Clearly the one on the right. So let's start with that. We'll start with the 1 over 1 minus sine of x minus 1 over 1 plus sine of x. Well, what can I do with that? Look at the first tip that I gave you. If you have fractions, get a common denominator and then combine the fractions together. So I have fractions. Let's get a common denominator. What's the common denominator between 1 minus sine of x and 1 plus sine of x? Well, it's 1 minus sine of x times 1 plus sine of x. So that means I multiply the first fraction by 1 plus sine of x, and I multiply the second fraction by 1 minus sine of x. And when I do that, I get on the bottom those two things multiplied together. 1 minus sine of x times 1 plus sine of x. Now notice that that minus that's in between the two fractions applies to everything in the fraction on the right. So I put the 1 minus sine of x in parentheses there. That way I distribute that minus into it. So I have 1 plus sine of x minus 1 plus sine of x once I distribute that minus that's in the middle there. Okay? On the bottom, let's FOIL that out. When I FOIL it out, I get 1 plus sine of x minus sine of x, so those cancel each other out, minus sine of x times sine of x, which is sine of x squared. So 1 minus sine squared x. How does the top simplify? Well, I have a positive 1 and a negative 1. Those cancel out. Then I have a sine of x and another sine of x. Sine of x plus sine of x becomes 2 sine of x. On the bottom, I have 1 minus sine squared of x. And I think about that fundamental trig identity I just dealt with of sine squared plus cosine squared equals 1. So 1 minus sine squared is equal to cosine squared. So I will replace that 1 minus sine squared that's on the bottom there with a cosine squared. Okay. So remember what I would want this to equal. I want it to equal 2 tangent of x secant of x. So I need to somehow make a tangent and a secant. Well, I know that right now I have sines and cosines, and I know tangent is sine over cosine. So let's rethink this as sine of x over cosine of x times 1 over cosine of x. Let's break up that cosine squared that's on the bottom as a cosine times a cosine. And think of it as two fractions that are multiplied together. That way, this sine of x over cosine of x becomes a tangent of x, and the 1 over cosine of x becomes secant of x. That gives me exactly what I wanted. I have the 2, I have the tangent of x, and I have the secant of x. And all of a sudden, I'm done. Number 5. Cosine of u over 1 minus sine u equals secant u plus tangent u. Again, I think adding and subtracting is more complicated than multiplying and dividing. So I'm going to start with the right-hand side. Now I could get there if I started with the left-hand side, but that one's a little tricky. We're going to start with the right-hand side. Secant of u plus tangent of u. And let's think about what we can do with that. Well, one trick would be rewrite them in terms of sines and cosines, because I know the other side of the equation, which is what I want it to be equal, only involves sines and cosines. So let's rewrite these things using sines and cosines. What's the secant of u? It's 1 over the cosine of u. What is the tangent of u? It's the sine of u over the cosine of u. And now all of a sudden I have two fractions with a common denominator of the cosine of u. Let's combine those. 1 plus sine of u over cosine of u. Well, that's interesting, because what I wanted this to be equal to is cosine of u over 1 minus sine of u. So kind of the reciprocal of this, but with a minus in front of the sign instead of a plus. So how do I get that to be what I want it to be? To remember is this left-hand side of the equation. Here's the trick. You ready? Are you? Maybe. Multiply this fraction by 1 minus sine of u over 1 minus sine of u. First of all, realize that you can do that. What you're really multiplying by is just the number 1, because 1 minus sine of u divided by itself is just 1. So I'm not changing this fraction by multiplying it by 1, because that doesn't change it. So I can multiply it by 1 minus sine of u over 1 minus sine of u. That's a perfectly legal move. We haven't done anything against the rules. The reason I want to do that is because now I'll FOIL out the top. When I FOIL out the top, I get 1 minus sine of u plus sine of u, so those middle terms cancel, minus sine of u squared, so sine squared u, over cosine of u times 1 minus sine of u. And I'm not going to distribute that cosine, because you'll see why in a minute. What is 1 minus sine squared of u? Cosine squared of u. Very good, because of that fundamental trig identity that says sine squared plus cosine squared equals 1. So now what I have is two cosines on the top, cosine squared of u on the top, and a cosine on the bottom. So I'll cancel out that cosine that's on the bottom with one of the ones that's on the top, leaving me with one of the cosines still on the top, and 1 minus sine of u on the bottom. Hey! That's exactly what I wanted. And number 6. One plus cosine of x over cosine of x equals tangent squared of x over secant x minus 1. Which side should I start with? Let's start with the right-hand side. Again, we can start with either one, so don't be scared. But I'll start with the right-hand side. Okay, so I've got the tangent squared. I could make that into sine squared over cosine squared. And I'd probably get there. But I also have this fundamental trig identity that says 1 plus tangent squared of x equals secant squared of x. That would mean that tangent squared of x was equal to secant squared of x minus 1. I just moved the 1 to the other side. So let's do that. Replace tangent squared with secant squared minus 1. Why do I want to do that? Because very similar to what I already have on the bottom. I have a secant of x minus 1. Does that mean I can just cancel out a secant, cancel out the 1s, and end up with secant of x? No, because I can't cancel anything that is added or subtracted into the top and the bottom. I can only cancel things that are multiplied. So the way it's written right now, I can't cancel anything. But secant squared of x minus 1 can be factored, because that is just a difference of squares. It is secant of x minus 1 times secant of x plus 1. And if you don't believe me, take what I just wrote, FOIL it out, and show that you get back secant squared of x minus 1. So now I have a secant of x minus 1 on the top and on the bottom, and those are gone. And I end up with secant of x plus 1. That's pretty cool, except that it's not what I want yet. What I want is 1 plus cosine of x over cosine of x. I've got secant of x plus 1. So, if I need everything to be cosines, let's rewrite the secant using cosine. And I know the secant is 1 over cosine. Okay? Now I've got two fractions, 1 over cosine of x plus 1 over 1. Let's get a common denominator of cosine by rewriting the 1 as cosine of x over cosine of x. Now let's combine those together. 1 plus cosine of x over cosine of x. Ho ho ho! That's what I want. Boom. I'm done. Isn't this fun? So the whole goal is to show that that equation is true. The way I show that equation is true is I take one of the sides, manipulate it, using those fundamental trig identities, using the fact that tangent is sine over cosine, using the fact that secant is 1 over cosine, that cosecant is 1 over sine, that cotangent is cosine over sine, manipulate it, which might involve getting a common denominator and combining fractions. It might involve factoring something, and then show that it ends up being exactly what the other side of the equation was. Therefore, that equation must be true. That's what we're doing here. Give your homework a try, and don't freak out.